Having told you that, let's think about what's really taking place when I'm doing a titration. If I'm doing a titration, let's pick on one in which I'm looking at bromethymol blue as an indicator. Here's a yellow pin and here's a blue pin. I always do this pretty famous example in class where I impregnate bromethymol blue onto t-shirts. I take some acetic acid and I pour some bromethymol blue into it, and then I put the t-shirt down in here, and it makes the t-shirt a nice yellow color. So I have this nice yellow colored t-shirt. Then I squirt some water on it around pH 8 or 9, and suddenly the t-shirt goes from being yellow to being blue. Pretty nice and easy to see there. Yellow, acid, blue, base. But let's think about what's really happening when this occurs. Let's draw this curve here and appreciate that there is a point right in here where I separate having had yellow over here from blue over here. And in fact, I can actually talk about the colors of my indicators in this way. Watch this. It's kind of neat. I can say that the pH of my solution is going to be equal to the Ka for my indicator times the ratio of the concentration of my yellow acid to the concentration of my blue base. After all, this is an acid-base reaction in which HA is going to go and form A minus. Yellow is going to form blue. It doesn't happen at once. It happens in the following way. So here's my beaker, and it's a bunch of yellow dots. Maybe it's 10 of them. And here's my beaker over here. When it's all base, it's a beaker filled with blue dots. This is literally what's going on. These are actual numbers of indicators, 10 yellow indicators, 10 blue indicators, and then what's in the middle? Well, what do you think's going on here in the middle? In the middle is the point where, oh my gosh, the amount of acid must be equal to the amount of base. I've got 5 yellows and 5 blues present at the same time. That's what happens at that point. The pH is equal to the pK of the indicator. I can draw this line back over here. This right here is the pK of my indicator. Well, at that point, what's actually taking place in solution? Well, you can imagine if I've got a solution right here which has 5 yellows and it's got 5 blues, well, then when you're looking at the solution, you know what you're seeing? You're seeing a green solution. That's what's actually happening in this transition that's occurring. As I go from yellow through green at perfection, where this indicator is a 1-to-1 ratio here, where the pH equals the pK of the indicator, on through to the blue. What is the range over which this actually happens? Well, it's the range over which I go from all yellow to 90% to 80% to 70%, 60, so on, all the way through. And over here, excess of blue all the way up to 100% or so of blue. That's a pH range typically of around 2 units or so. So that if this right here happens to be a P indicator at around 8 or so, then between pH 7 and pH 9, I'm seeing my solution becoming increasingly green into increasingly blue. That 2 order of magnitude change from all yellow through to equal blue and yellow to all blue is a region of great transition. Fortunately for us, when we look at pH curves, those pH curves usually span more than 2 pH units. And they occur very quickly. It takes very little volume to spike that up there. So that when I'm looking at a titration curve, and I decide that I'm going to draw it here, and I'm coming along, then this whole change here is taking place really not in a region that's as big as this, but frankly in a region which is really very narrow in terms of the volume that's being added. And as a result, I go from being an all yellow container here to an all blue container here in this huge pH change in just a few drops of liquid. For you doing titrations in the lab, you've seen this before. You've noticed that if you're titrating and it's yellow, it's yellow, it's yellow, it's yellow, you look, well, blue! Oh my gosh, I missed it. That's why people who learn to do titrations learn to do them so that only the tiniest amount of volume of the base is being added, quarters of a milliliter droplets being added, so that you can get to the point where you can actually see that green. That's the holy grail of titration, is to actually see the green color there between the yellow and the blue. Now, of course, having said that, one of the funny things about this is that once you get that green there, you wait about 2 seconds and you look back, suddenly that green has gone back to yellow. Why? Because there's carbon dioxide in the air, which we'll learn is an acid, and it turns that green color back into yellow. But this gives you a sense about what's taking place as we burrow in and take a look at that pK indicator region, that region where we change from one color to the next very quickly with just a few drops of strong acid or strong base added.